Good day to you all. My name's James. Thank you so much for joining me at my PE exam. And look, what I'm going to do in this session is I'm going to try and develop a skill with you. So this is specifically a skill that we're going to develop. It includes some knowledge as well, but we're looking at a skill of actually performing these pin diagrams, sometimes referred to as vector diagrams or free body diagrams. So just bear in mind it could be referred to differently if you're answering this within an exam question. It could be one of those terms, a vector diagram or a free body diagram, or indeed, as I've written it, a pin diagram. It really means the same thing. And I've effectively put in that we've got 3 rules that we are going to have to stick to pick up our marks. And I'll show you as we go along the application of these 3 rules. First of all, let's have a look at Roger Federer in this image here. Now, the first thing we can say about Roger in this sense is that he's in the ready position, right? So because he's in the ready position, he is indicating no movement. Remember that with no movement, we can also refer to that as stationary or a constant velocity, albeit that the constant velocity is at 0 meters per second, okay? So what can we do to illustrate this notion of no movement? Well, I'm going to say to you, first of all, we have to show on our vector diagram the idea of 0 net force. Whenever there is constant velocity, that includes being stationary, we have to show 0 net force. Net just means total force. Let me show you how I would do that. First of all, I want to think about the dominant force which is acting here. Now, there are only vertical forces acting in this case. So I'm going to take his center of mass, which I'm going to sort of produce as roughly his navel, his belly button here. And you're going to do this with a ruler. I'm just doing it freehand. I'm going to draw a vector arrow downwards to about that sort of length. And I'm going to label it as W. This is Roger Federer's weight force. W equals weight force, not his mass. We have to multiply mass by the effect of gravity to get the weight force. So if I was to leave the illustration like that, what would we expect Roger to do here? Well, it would effectively mean that he was going to sink into the ground.